Obese-Creative Diagnostics obese signaling pathway. Obesity means a person who's very overweight, at least 20% higher than it should be. Obesity is a common problem in the US and worldwide. According to National Health and Nutrition Examination Survey data, it's estimated to affect around 30% adults and around 20% children aged 10 to 11. For children, rates of obesity have risen even faster. Obesity is the second cause of death in the world and has reached epidemic proportions in recent years. Obesity and overweight involve an abnormal and excessive fat accumulation that negatively affects the health status. According to the World Health Organization, if body mass index (BMI) is equal or greater than 25 kilograms, it is considered overweight, whereas the BMI higher than 30 kilograms defines obesity. It stems from a positive mismatch between energy intake and energy expenditure. Western societies are obesogenic environments where people have become sedentary while food portions have grown supersized, and highly processed convenience foods and soft drinks provide a glut of calories throughout the day. Actually, obesity is a consequence of complex interactions among genetic, environmental, socioeconomic, dietary factors, and lifestyle factors. Lifestyle factors, particularly in early life, such as exposure to antibiotics, and other early life environmental modifiers which may be linked with epigenetic changes, are coming under scrutiny as risk factors for obesity later in life. The rapidity at which obesity is increasing in westernized or socioeconomically developed countries is not fully explained by traditional theories of weight gain. Characteristics of obesity include low-grade inflammation, altered microbiota, and increased tone of the endocannabinoid system. There are three major obese signaling pathways: FFS, insulin, SFS. Obesity individuals secrete less adiponectin than lean individuals. The decreased production of adiponectin, in combination with the inability of adipose tissue to store the surplus free fatty acids, can be considered to reflect adipose tissue dysfunction. Under normal conditions, adiponectin increases insulin sensitivity directly, by stimulating tyrosine phosphorylation of the insulin receptor. Adiponectin, binding to adiporeceptor R1-R2, can activate 5-AMP-activated protein kinase (AMPK), leading to increased fatty acid oxidation and decreased influx of FFS into the liver. Independent of AMPK activation, adiponectin decreases the production of reactive oxygen species (ROS), which may result in decreased activation of mitogen-activated protein kinase (AMPK) and thereby inhibition of cell proliferation. Cells of the innate immune system produce cytokines and other factors that affect insulin signaling and result in the development of insulin resistance, which is frequently seen in obesity. Obesity induces lipolysis and release of pro-inflammatory FFSN factors, such as tumor necrosis factor alpha, TNF-alpha. TNF-alpha initiates signaling through tumor necrosis factor receptor 1, TNFR1, with the consequent regulation of gene expression, recruiting TNFR1-associated death domain, TRDD, TNF receptor-associated factor 2, TRF2, and receptor-interacting protein, RIP. They then induce TGF-beta-activated kinase 1, TAK1, and TAK1-TAB complex, which activates NF-kappa B essential modulator, NEMO, IKK-alpha, and IKK-beta. The activation of the I-kappa B kinase leads to phosphorylation of I-kappa B and release of NF-kappa B, which then translocates to the nucleus and binds to the promoters of pro-inflammatory genes and initiates transcription. Insulin binding to insulin receptor (IR) leads to the activation of receptor tyrosine kinase and receptor phosphorylation, which enables the binding of docking proteins such as insulin receptor substrates (IRS). It then stimulates cell proliferation through several downstream signaling networks, including the phosphatidylinobutyl 3 kinase (PI3K), a KT system, mammalian target of rapamycin (mTOR), and the MAPK systems. Saturated fatty acids (SFAS) are the major type of fats, including lauric, myristic, palmitic and stearic acids. They can bind to Phe2Na, an endogenous ligand of toll-like receptor 2 (TLR2) or TLR4, and initiate transcription of interferon regulatory factor 3 (IRF3) by activating the myeloid differentiation primary response protein 88 (MYD88) TIR domain-containing adaptor-inducing interferon beta (TRIF) dependent pathway. TNF receptor-associated factor 3 (TRF3) is a ubiquitin ligase recruited to both MYD88 and TRIF-assembled signaling complexes. The IKK-related kinases, TBK1 and IKK-epsilon activate IRF3, and activated IRF3 then translocates to the nucleus and binds to target DNA sequences. Obesity is a chronic disease and is associated with numerous comorbidities, including type 2 diabetes mellitus, cardiovascular disease, hypertension, and dyslipidemia. Moreover, obesity is a risk factor for major causes of morbidity and mortality, and increasing evidence shows that a binge eating disorder affects a subset of obese patients. The failure of these efforts points to the existence of additional, non-homeostatic mechanisms that mediate feeding behavior. Indeed, redundancy in these pathways makes obesity therapy difficult, as it is further evidenced by the failure of newer drugs targeting distinct aspects of these systems. Thus, the epidemic of obesity begs for novel concepts and therapeutic targets that ideally treat food use disorders and related comorbidities such as drug addiction and neuropsychiatric disorders. Do you want to know more about obesity? Do not hesitate to contact us for any questions. Email us at info@creative-diagnostics.com. Thank you.